I'm going to make a report on the theme of the following theme, that is scientific and educational framework of the Department of Management of Ural State Forest Engineering University. Many kinds of human activity, such as timber industry, production, agriculture, and many others, are attended with either emission or absorption of carbon dioxide. And this why we can describe it in terms of carbon dioxide. We consider the difference between carbon emission and its absorption as an efficiency indicator of an activity, which also allows revealing pollution sources and zero polluting factors. The full carbon cycle is displayed on figure 1. Earth's carbon cycle is dominated by the ocean, which absorbs about 50% of the total carbon released into the atmosphere by the human activity. But forests keep playing an important role in carbon cycle of the Earth, as they make up about 80% of the terrestrial ecosystem exchange. So there are two important points. One, we must to determine emission level of carbon, and the second, we must determine the deposition level of carbon. Let's begin with the emission. In geosphere, there are two methods of estimation of carbon dioxide emission level. The first was worked out by Professor Sannikov, Professor Gertz, and other scientists. This model based on the means of RFID technologies, RFID sensors. These sensors are fixed on trees and give possibilities of carbon emission rate monitoring. The scheme of RFID technology of forest data collecting is shown on the figure 2. Then the second method of carbon emission estimating is by the means of atmosphere carbon concentration estimating. In Russia, such estimating is run at 4 stations. 2 of them are situated in background environmental condition, and 2 others are situated near the places of large-scale pollution. Information about these 4 stations is shown in table 1. According to Tereberka and Tixi stations, which are most interested in terms of estimation determination, data during the period of 2000 to 2012. The following values of carbon concentration and its annual growth were obtained, as shown in the table 2. In the Department of Management of Ural State Forest Engineering University, there are also 3 methods for estimating of ecosystem carbon deposition. The first is by the means of forest biomass regression model that had been worked out by Professor Soitsev. These models combine the data of biomass and primary production, which were obtained on the plots, with the data of State Forest Resources Counting Committee. And it was prepared for the territory of the Ural Federal District, that includes 10 territorial entities. This model also allow calculation of the total carbon pool of forest biomass and annual carbon deposition to biomass on the following level: the Federal District, Administration Unit, Forest Areas, Forestries, Quarters, and Development. The general view of the model for biomass deposition is the following. The model describing the dependence of dry biomass of each fraction by age and stock are calculated for each species separately. Then the model coefficients for major tree species are computed. Here is the example of the model coefficients for such species as large. And the same table is compiled for biomass annual growth as well. These models have been accomplished within an automated carbon deposition information system. There are publications on it, and we decided to make use of Chebyshev's method to formalize and automate the counting procedures. The general view of Chebyshev's methods of his equation is shown within this sheet. Then we rearranged the equation and factored out independent variables to calculate the multiplier of each independent variable separately. We call these multipliers as regression equation coefficients, and the result of rearranging of this equation, which includes 4 independent variables, and is shown here. Then, on the basis of this algorithm, we developed some applications by the means of database and natural software. The applications can be used as in scientific activity as well as in studying process. Data search application allows searching biomass component data of a particular farm or a forestry, a new name of it. And 3 searching criteria are to be identified for searching that they are forest farm name, species, and age group. We have another application that has more advanced function. By the means of this application, one can view all the age group data of a particular species of a forest farm, and also we can change forested areas and stem volume. Here they are. And stem volumes, and recalculate biomass values by new data. We can press, also we can recalculate the regression equation coefficients in 2 ways. We can do it manually with the help of this application, or we can run a procedure for a particular species on the basis of sample plots data with the help of the presented algorithm. To perform this procedure, we should make use of main menu of the system, and firstly we can change the same sample plot data by with the help of plot data edit application. And after saving changes, we can change dependent and independent variables for including them into the equations. Dependent and independent variables. Also, within this system, there are 2 maps available. First for biomass distribution, and the second for annual growth of biomass. Biomass distribution map is shown here. All the here are all the biomass data and the annual growth biomass data. The second method for carbon deposition estimating that exists in Ural State Forest Engineering University is connected with remote sensing, and at the Ural State University, Federal one, there is distant monitoring center with the access to images of 4 satellites. They allow we can get images with a resolution from 50 to 2000 meters, and in 2030 Ural State University has held a competition of research centers working in 4 particular scientific and technological areas. The William Centers are funded by the government, and 9 scientists of the Department of Management of USFEO and scientists from Ural State University combined in a research center which was called the Center for Environmental Management and Monitoring, have become one of the winners. The main purpose of this center is Ural region economic activities monitoring on the basis of carbon deposition rate analysis with the help of satellite data. Satellite images also allow us creating of carbon deposition rate changing estimated models, and these estimations give possibilities to reveal the rate and the resources of carbon pollution and to plan economical activity of enterprises and municipalities, minimizing the environmental damage and optimizing the use of natural resources. That decent monitoring center is equipped by a software system of remote sensing data processing and geographical information systems. Very well known are these, RVU. And all that gives the possibilities to obtain vegetation distribution, soil conditions and soil forming rocks map, landscape condition map, forest distribution by dominant species and age group. Here are the result of this determination: soils condition and soils forming map, landscape conditions, distribution, and forest distribution by dominant species and age groups. The third model, which is run in the Department of Management, is CVM model. It's a Canadian model, official model, spread for free for anyone. And CVM model is firstly, it's a landscape model of forest ecosystem carbon dynamics that forest managers and analysts can use to assess the carbon stock and change in carbon stock in the operational forest areas. Although developed primarily to assess carbon dynamics at the operational scale, the model can also be used to explore carbon dynamics for smaller areas down to the stand level. The model can be used to assess past changes in carbon stock using information on management actions and natural disturbances that have already occurred, or to evaluate future changes that would result from scenarios of management actions and natural disturbances. This model accounts for carbon stock and stock changes in three biomass and dead organic matter pools, as shown in Figure 16. The model also allows to assess the dynamics of such indices as stocks, stock changes, age classes, and advanced ones, such as net primary production, net ecosystem production, and others. Also, we have researchers in such field of economics as forest ecosystem total economic value estimator. Within this work, a model for optimization of forest product range was obtained. The model provides for 3 cases. The first is when a municipality is a producer and itself determines the range. Here are the model for it. The second case, when a tenant is a producer and itself determines the range. Another one. And the third case is when a tenant is a producer, but a municipality determines the range. Excuse me. Net ecosystem production, ecosystem total economic value, and the demand for forest products of different types are used as the main limitations within this model. For the aim of ecosystems total economic value, calculating the following formula was deduced. within this model, the STP, the value of wood resources, SNT and net can be counted with the help of regression models and CBM model. The other indicators, such as non-wood resources value, is calculated as the sum of values of nuts, mushrooms, berries, fruits. If we don't have enough time, I can. Okay. Forest functions value also is calculated as the sum of environmental forest functions and social forest functions, such as biodiversity, recreational function, and others. And we have the methods for counting every one of these components. So, all the technologies and research result that have been listed allow running studying programs in the following areas. If concerning RFID technologies that allow achieve such indicators as weight, height, crown diameter, and others, allow to run in such programs as forest measurement technologies, indicators choice for forest condition monitoring and forest condition monitoring. Then, carbon concentration estimating does not allow running a separate course, but it gives possibilities. It very helps calculating the difference between the emission and deposition of carbon. That is very helpful for other results and switching. Forest biomass and its annual growth regression models that allow calculating such indicators as total biomass and annual growth on these levels, and allow to run studying programs as regression models technologies, data extrapolations, Chebyshev's method as means for regression analysis. Remote sensing means indicators, vegetation distribution, landscape condition, all that we saw within the figures. And the studying program that can be run here are geographic information systems, digital image processing, basics of remote sensing. CBM model, indicators, stocks, stock changes, a lot of them, age classes, advanced ones, and studying programs, forest growth scenarios, influence of management actions and natural disturbances, forest future conditions, condition forecasting. Ecosystem total economic model, indicators, wood, non-wood, resources, value, future information value, and other, and correspondingly the method for calculating that. Combination of regression models, RFID technologies, and ecosystem total economic model or value gives possibilities to obtain such courses: forest production rate utilization, as on the level of municipality, as for an enterprise of timber industry. A combination of regression models, RFID technologies, SBM model, and ecosystem total economic value allows to calculate the listed indicators and such programs as economical and ecological planning for different ways of silvicultural management and for timber industry management. Also silviculture optimization, timber industry optimization, production facilities planning and optimization, and other connected. Combination of all, no, not of all, but of regression model, carbon concentration estimating, RFID technologies, SBR model, and remote sensing. And ecosystem total economic value allows to achieve such studying program as identification and monitoring of foreign forest distribution, forest species composition determination, mature and over-mature forest monitoring, reforestation control on deforested areas and on burnt and rainfalls areas, shelter balance condition monitors, forest disturbances monitoring, pollution monitoring, forest future condition forecast, forest fuel monitoring and mapping, illegal logging monitoring, ecological monitoring, agricultural land resources monitoring. References? Questions?
Thank you. So, well, just a comment. When I was studying in 1980s in a place which corresponds to your place where you have these summer courses, it's about 100 kilometers from Joensuu. There was one of our professors, Professor Seppo Kellomäki, was building up his first test facilities in the forest, where he put kind of glass carpets around growing trees, and he developed a system for measuring the CO2 balance, the photosynthesis and respiration of individual trees in natural conditions and around the year. And we thought that this is crazy. Who needs this kind of information? But it didn't went too many years after I finished my studies when this talk about climate change came, and actually he was one of the researchers in a group which got a Nobel Prize as a part of this IPCC modeling group, and really in less than 10 years we changed from cubic meters to CO tons and carbon tons, and really that's a big change that has happened in forestry and forest sector and also other sectors. And okay, Professor Kellomäki is now retired more than 1 year ago, but he produced from this group more than 10 doctors in this field, and really this ecosystem modeling, and how do you say, this kind of process modeling where you can kind of make simulations and change the environmental factors and look how they are affecting the growth of trees and even survival. That has been very important kind of line in forest research in Joensuu and also in many places. So I think that this is very interesting topic, and I recommend you to be in contact with our researchers.
I'd like to add that Mikhail is one of the best our researchers. He is a bit nervous because he is a real scientist. He likes to do science, and it is not often when he took part in such events, and we hope that some nervous was not a reason to take it wrong.
No, I didn't show that. It was very cool.
Thank you.
Cool presentation, but maybe one thing that I'd like to maybe to concentrate for the future is that you are doing quite a lot of basic research in this modeling, but it would be nice to have kind of maybe more examples of practical solutions of this research you are doing, maybe in a form of questions like what we are doing in all the EU countries is that we have to give results on how much our forests are binding more carbon, are they net carbon sources or are they sinks, and how many tons what is the balance in our forests in Finland or in certain areas.
Mr. Tahvananin,
Doing the practical task for estimating the balance between
maybe even
emission, absorption,
both the kind of goals for what you think that your results can be used for, so that you have already a clear idea what you are
practical
making
fields.
this. Yeah. And maybe also answering these questions later.
Right, it led to that.
Mr. Tahvananin, I also want to add that now we have courses for teachers, for different faculties, departments, where our foreign international department will give more information about the best practices in international lectures. And also we have some examples from Oxford, Berkeley, MIT and other universities, and I hope till we start this innovation experience will be implemented in our presentation. We try our best, believe me. We are hardworking.
Thank you.